Ever wondered how you can run Windows on a Mac, or play old-school video games on your brand-new PC? Or how massive companies like Google and Amazon manage countless applications on just a few physical servers? The magic behind all of this is called virtualization, and today we're going to break down exactly how it works. Stick around, because by the end of this video, you'll understand this core piece of modern technology. First, if you're interested in tech deep dives like this one, make sure to hit that like button, subscribe, and ring the notification bell so you don't miss our future videos. All right, let's start with the basics. What is virtualization? In simple terms, virtualization is the process of creating a virtual rather than physical version of something, like a server, a desktop, a storage device, or even a network. It's like having a computer inside your computer. The main goal is to use one physical machine to run multiple independent virtual machines. Think of it like a single apartment building with many separate apartments inside. The building is your physical computer, and each apartment is a virtual machine, or a VM. Each VM has its own tenants, the operating system and applications, and they don't interfere with each other. So, how is this possible? The hypervisor is the manager of the entire building. It sits between the physical hardware and the virtual machines. Its job is to manage and allocate the physical resources, like the CPU processing power, the memory or RAM, and the storage to each of the virtual machines that need them. The hypervisor makes sure that each VM gets the resources it asks for, and it prevents them from stepping on each other's toes. It's the traffic cop, the resource manager, and the security guard all rolled into one. There are two main types of hypervisors. First, we have Type 1, also known as a bare metal hypervisor. This type runs directly on the host machine's physical hardware, kind of like an operating system itself. It's super efficient and secure, which is why it's the go-to choice for big data centers and enterprise environments. Think of products like VMware, ESXi, or Microsoft Hyper-V. They are installed first, and then the operating systems for the virtual machines are installed on top of them. Then there's the Type 2 hypervisor, also called a hosted hypervisor. This type runs as an application on top of an existing operating system. So, you'd have your computer, your main operating system, like Windows or Mac OS, and then you install the hypervisor software just like you'd install any other program. Examples you might have heard of are VirtualBox or VMware Workstation. This type is great for developers, testers, or anyone who wants to try out a different operating system without having to buy a whole new computer. It's super convenient, but slightly less efficient than a Type 1 hypervisor because there's an extra layer, the host operating system, that the resources have to pass through. Let's get a bit more technical. When a virtual machine is running, it thinks it has its own dedicated hardware. It sees a virtual CPU, virtual RAM, and a virtual hard disk. But in reality, the hypervisor is cleverly tricking it. The hypervisor intercepts the commands from the VM to the hardware. For example, when a VM wants to save a file, it sends a command to what it thinks is its hard drive. The hypervisor catches that command and translates it into an action on the actual physical hard drive, saving the data into a single large file that represents the VM's entire virtual disk. The same happens with CPU instructions and memory access. The hypervisor juggles requests from all the VMIs, schedules them, and sends them to the physical CPU for processing, making sure everything runs smoothly and efficiently. So, why go through all this trouble? The benefits are huge. First, efficiency and cost savings. Instead of having 10 different physical servers, each running at only 10% capacity, you can have one powerful server running 10 virtual machines, utilizing close to 100% of its resources. This saves money on hardware, electricity, and cooling. Second, it provides flexibility and rapid deployment. Need a new server for testing? You can spin up a new VM in minutes instead of days or weeks. Third, it improves disaster recovery. You can easily back up an entire virtual machine as a single file and restore it on another physical machine if something goes wrong. This is a game changer for business continuity, and that's the essence of virtualization. It's a powerful technology that allows us to do more with less, creating virtual environments that are isolated, flexible, and efficient. From the cloud services we use every day to the software development happening behind the scenes, virtualization is a fundamental pillar of modern computing. I hope this has cleared things up for you. If you found this video helpful, please give it a thumbs up. It really helps the channel. And don't forget to subscribe and hit that notification bell for more tech explanations. Thanks for watching, and I'll see you in the next one.